Okay. We have an electric vehicle infrastructure plan. Dr. Larry Malik's group.
Hello, everyone. Thanks for joining us today. My name is Noah Tadiyevsky. My teammates are Zach Peel, Sarah Bueller, and Logan Muir. And our faculty sponsor is Dr. Larry Malik. And our project is over electrical vehicle infrastructure plan. When we first started our project, we were like, what is the need for electric vehicle charging on campus? And we found out the biggest thing was the growth of EV popularity on campus, and the accessibility to green solutions other than the gasoline and diesel. And Western wanted to demonstrate the commitment to being green on the university. And most importantly, we wanted to serve the needs of Western EV drivers on campus. Electric vehicle popularity growth in the EV market today. There's advantages in the technology of batteries and charging capabilities. So you can go like longer ranges and stuff like that. Then EV requires charging stations, grids, and stuff. So there's going to be 2030, 500,000 charging stations in the U.S. And the popular growth is also due to the government grants and funding and the new consumer bills that give you incentives to buy electric. Back in 2012, Western got a grant for 20 ChargePoint chargers to have on campus. There are a variety of level 1 and level 2 charging capabilities, but most level 2. They're connected to the national ChargePoint network. They have cloud connectivity, so you can see where the chargers are located on campus. And also you can pay through an app on your phone. It's easier and simpler and hands-free. So you can see here, back in 2012, we had 20 stations. We had 15 at Miller Auditorium, 6 at the physical plant, 1 at Sangren, 1 at the city office, and 1 here at Floyd. Then over time, here in 2020, you can see there's only 11 at Miller, 2 at the physical plant closed, Sangren, Stanley, and Floyd are still active. And today, there's only 5 at Miller, 1 at Stanley office, and the rest are offline. In the demand in the United States today, there's 96,000 charging stations in the United States. 1.4 million EVs are sold in 2020. It's estimated 7 million in 2025. And in Michigan, there's 18,000 EVs on the roads in 2020, and there's 1,486 charging stations total. You can see by this graph, projected that from 2010 to 2030, the EV sales and the amount of vehicles on the road. And by this, you can see how it's trending upwards, and our charging stations are going down. We need to go back up with the demand by the need. So what is an electric vehicle? There's 3 main electric vehicles that we see on campus today. There's battery electric vehicles, BEV, plug-in electric vehicles, PHEV, and hybrid electric vehicles. Battery electric vehicles, they're 100% fully electric, not powered by internal combustion engines. Plug-in hybrids, batteries power the electric motors, the wheels of internal combustion engines, up to 10 to 40 mile an hour trip. Then HEV, electric motors for 1 to 5 miles, then the internal combustion turns on and takes over. The goal for our project is to provide solutions to meet the needs of the growing population of EV drivers in Western Michigan's campus.
Yep, so the deliverables for this project include a forecast for the growth of EVs on campus, as well as recommendations pertaining to the charger brand alternatives, where to put them, and the department ownership, and as well as a solution to the overstaying issue, which we have called charger hub. Constraints for our project includes some data limitations. It is a new technology and it is subject to change frequently. This would include the battery advances and whatnot, always driving the price down. There are also privacy concerns with parking services information. We're not able to obtain everything that we would have wanted to. And there are engineering constraints, such as there are 20 current stations that are not all working. We would have to possibly remove parking spots to make more, which include building new stations. And then there's also the charger pumping issue. So to get around the lack of information on parking services, we turn to work sampling, which is a method to investigate the proportion of time spent on various activities and it is done by taking many observations at random intervals. So for this to be valid, it has to be random, unbiased, and independent. The process involves a pilot study, which is used to calculate the total number of observations necessary, and then we can design the study, perform the study, and then check the accuracy. So for our plan, we wanted to get the proportion of EVs on campus. And to do this, we would visit the parking lots, which were just randomized. They were on main campus as well as Parkview. And then we also wanted to get the amount of time that the chargers are utilized. That we visited the off-brand charger here at Parkview, as well as the remaining 5 at Miller and the one at the sustainability office. The plan went from August 25th to October 6th at random times between 8 a.m. and 6 p.m. in order to get the most accurate student data. And some additional notes, we tried to write down the EV models that we saw, took some pictures, and we also created a hybrid vehicle subgroup just for additional data. So some of our results are shown here for the charger utilization. You can see that the overall idle time ended up being 53.2%, which after checking accuracy, we got the true idle time to be 46.6% to 59.8%. An additional note would be that the Office of Sustainability has a much higher utilization time, because that is where Western's last remaining electric vehicle goes to charge. So for the EV proportion, we got 3,945 vehicles counted, and that gave us a 2.8% EV proportion. Again, checking the accuracy, we got 2.36 to 3.24% EV on campus. And an additional note that we found was that Miller Auditorium has the highest percent at 5.1. So using this data, as well as the EV growth per year shown below, thanks to the moderate PV scenario, as well as keeping in mind that we wanted to remain below 75% utilization in order to account for fluctuations such as sporting events or shows at the Miller Auditorium. We created the graph on the left. The blue is the number of chargers that they will need for each year up to 2030, and the green is the utilization rate. So by 2030, we would need 9 chargers. An alternative to this would be using a grant from consumers currently. We could get 10 now and have them paid for. And the green would show that the utilization would start pretty low, but it would climb and come close to the desired.
So in addition to the work sampling, we also conducted a 5-week campus climate survey to determine some of the habits of the drivers on campus. Based on the survey, we determined that a good majority of the drivers only plug into the chargers 1 day per week, and most of them plug in between 8 a.m. and 11 a.m. And then most of the charging sessions that occur are between 2 to 4 hours. And for the relationship to Western with these drivers, most of them are faculty and staff, followed by students. And then we noticed an influx of drivers that were visitors plugging in during game days. And then along with the survey, we also provided a space for driver feedback. The positive feedback that we got were that the drivers were happy that there were stations available for them to use, but they were dissatisfied with the amount of stations and how many of them were broken. And most of these drivers did say that they'd be willing to pay for the stations if it meant that they could have more that were in operation.
So since we now figured out that our current infrastructure plan is not going to work for very long, we had to come up with alternatives, and we chose to do 4 alternatives to offer the school. For the constraints we have been limited to with 10 stations of the initial installation from the Consumers Grant, the current locations already on campus that exist, and a 4-hour per session usage. And then some of the variables we looked at when comparing these alternatives was the installation responsibility, whether it was on the school or the company, how much power output each station would have, the compatibility, whether it's easy to use or not, the price per hour of charging in session, if there's a payment method or you'd have to pull the quarters in like a meter, how it looked, and the ease of locating it on campus. So the first option we came up with was the weatherproof outlet, similar to the one as if you were at a campground. You just plug in and go. It came with 3 power output options, and the driver must provide their own cable. And there is no form of payment currently on it, and not located on any charging app, so it'd be very difficult to find. The cost breakdown would all go on to the school or hiring an electrician to put them in, and installation and building costs of any additional one after that. Our next option was the Blink charger. It is a level 2 charger with a 9.2 kilowatt hour output, and it has a cable that has an adapter for the most common connector in North America, and it has an app that can save your payment and makes it easier to use. Also allows you to locate them and it tells you whether they're in use or not. It will have a $2 parking fee plus a $40 or 40-cent per hour charging rate. Cost breakdown for the Blink comes out to the initial cost of the station and stand go to the company, as well as the installation costs, but Blink will get 60% of the revenue. And on the other hand, the school will get 40% of the revenue and be responsible for upkeep and maintenance. Our next one is ChargePoint level 2 chargers with 7 kilowatt hour output. They are NEMA compatible and also charge Teslas. The ChargePoint also has an app, and it's easier with QR code. That does make it easy to find the charging station and whether it's in use or not. And that will be done with a $2 per session charge plus 25 cents per hour. Cost breakdown on that is the station and stand, as well as installation, will be all on ChargePoint. But Western will be responsible for software and system updates and costs, as well as maintenance, but they will get to receive 100% of the revenue. On top of that, Consumers Energy Grant covers the first 10 stations, and anything after that, the school will have to cover over themselves. And our final option was the NLX Juice Box, also a level 2 charger with 9.6 kilowatt hour output. It is also NEMA compatible with Tesla chargers. It also has an app that can use QR codes to make payments very easy, and locating them also very easy. Also a $2 per session charge at 45 cents per hour. Cost breakdown is similar on this one as well, with station, stand, and installation all on the company, receiving 60% of total revenue. The school has to pay the annual system costs, the maintenance, but they will receive 40% of the total revenue. These are also covered under the Consumers Grant, similar to the ChargePoint. The first 10 stations will be covered, and then any additional station after that will be on the school. So in order to compare all of these things, we decided to make a Pew matrix to compare our quantitative data and non-quantitative data all in a similar manner. Some of the criteria we had was the implementation, how much it costs to implement them and how easy it was to do that, and the recurring costs such as maintenance and systems fees, as well as the usability, how compatible they were to other cars and things like that, and what kind of revenue it could generate for the school, whether it was positive or not. For the ChargePoint and NLX, as you can see, what boosted them ahead of the Blink and the outlets was the Consumers Energy Initiative grant that the school would receive for getting them, as well as locatability and visual appeal to the eye.
So we also did a cost revenue model to determine the potential revenue that would come back to Western Michigan University. We based this all off of the total revenue that would be used for 75% of the utilization, and then the percent that went to the supplier, and then the cut we would get, and then our installation of parts and the maintenance fees. The maintenance fees were determined as 5% of the total revenue, and then the systems fees were determined by the individual companies. So ChargePoint was our #1 revenue at $9,222 a year, followed by Blink, which is $6,731. But Blink was out of the running because of the Pew matrix on the previous slide. And then the Weatherproof Outlets were surprising to us at how much they would actually cost the university. The first year that they would be implemented will be $11,547 for installation, and then $577 every year after. So as you can see in this graph, this is for the next 5 years after installation. The waterproof outlets continuously go down while the ChargePoint outlets bring in the biggest revenue. So with all this data considered, we recommended that ChargePoint were the stations that should be purchased by Western Michigan University. We decided that the 10 stations should be purchased using the Consumer's Energy Grant. And then Western should set a price at $2 per 4-hour session and then 25 cents for every hour that they are plugged in. And we decided these were had the simplest payment and the easiest to be located on any app, with the estimated $9,222 in positive revenue. The locations that we decided were similar to the current ones, with 7 at Miller Auditorium, 1 at Sangren Hall, 1 at the Office of Sustainability, 1 at Floyd Hall, with none at the physical plant because that's not a popular parking spot for visitors or faculty and staff. We decided that one functional area should have ownership over the stations. The facilities management will be taking over the general upkeep of the stations, and they'll be responsible for contacting the provider of the stations for any additional assistance that they need, whether it be for maintenance or systems. And then they will be receiving the revenue for the stations and making all the cost decisions for any additional stations that we might need. And then to prevent the charger hogging issue, the stations will be treated as an all passes parking spot. So any visitor, faculty, staff, or student can park there, but they must have a pass to park at these stations. And while they are parked at these stations, they must be plugged in and charging. But if they do overstay their 4-hour session or they're parked there and not plugged in, there will be $15 tickets issued, similar to parking meters. And these stations will be monitored by parking services and treated the same as parking meters. So to wrap things up, we believe it would be in Western Michigan's best interest to purchase 10 ChargePoint chargers via the Consumer's Energy Grant and locate them in 4 places across campus, and they'll be monitored by the facilities management team to help meet the growing needs of EVs on campus. We would like to thank Mr. Jeff Spolstra, the Director of the Office of Sustainability, and Mr. Pete Strastas, the Associate Vice President of Facilities Management, for their assistance throughout the project. And thank you all for coming. Are there any questions we can answer? Yes.
Does the facility group of Western have their own master operation?
We spoke to them because we thought, well, maybe some students could help doing it, just like to learn. And then because there's current stations that already exist that need to come out. So we're thinking we can donate those so they can work on them as well. Just to maybe save a little bit, but I don't know if ChargePoint or any that they have to do it or not.
4 hours at a time to fully charge most all these cars?
Most vehicles, yes. Because based on the survey, we did have the average commute time, and it was usually about 15 miles, which is more than enough for a charge to cover.
Any other questions in the room? If there are any questions online, you can put them in the chat, or please unmute yourself and you can ask them now. I do have a response. I appreciate you and your work from a person whose name I cannot pronounce. Dr. Aller, however, says it's a valuable project. Congratulations. Excellent presentation. Now, if there's nothing else, thank you very much. Good work.